Yes, hi. So my name is Cesar Pham. I'm an aspiring data scientist here at the UCI School of Business. And these are some of my teammates, Edward, Dylan, and Ping. Would you guys like to introduce yourself?
Hi, my name is Dylan Nguyen, and I'm a first-year undergrad student at Rio Hondo College. I aspire to transfer to a four-year university, and currently I'm studying business administration. So yeah.
Hi, my name is Edward. I'm a MSBA student in UC Irvine, and I'm really looking for a Search Hackathon.
Hi, I'm Ping. I'm also an MSBA student. So yeah, trying to leverage our skills on this hackathon. Yeah.
Awesome. So let's go ahead and jump right into it. I'm going to go ahead and share my screen so that we can see the PowerPoint. All right, is everyone able to see my screen?
Yes.
Awesome. Okay, so quick roadmap. Our ultimate goal was can be broken down, I guess, into 3 steps. 1, address the question of the hackathon. What is the ultimate risk profile? Who should we be targeting our solution to? And 3, what is our solution? We spent maybe the first 3 days focusing on addressing these 2 problems. Who is our target audience? And what exactly is the pain point that we need to address? We'll first go over our methodologies, go over our findings that we can substantiate our ultimate conclusion. And then at the very end, we'll go over the solution itself and the prototype we designed to address the pain points of our target audience. We'll go ahead and move on to the next slide. So in terms of how we approach this problem, we tried to do some exploratory data analysis. And when we were looking through all this information that we were provided, we saw that a lot of the information might not have been very significant. For example, looking at Twitter itself, although it was only one of maybe a couple dozen sources, it represented almost, I believe, 70%, 80% of our entire data set. This obviously is an issue because it does not represent the entire population of those affected by the coronavirus. It's really a specific pool of users. A little bit of pre-processing, which included removing duplicates, missing values, substantially reduced our data set. We then broke it down by sentiment, looking at how exactly our users, our sources, what their sentiment were across all our different platforms. You know, this definitely did help us gain a direction, but it really didn't yield too much information either. So we took another step, went another step further. We looked at the sentiment based on the sources that they came from. For example, United States, Great Britain, Brazil, countries like that. And you do see that there is more uniform distribution now. Most of the sentiments are neutral. For the most part, the ones that remained were positive, and then there were negative. Looking further into it, though, we did realize that a lot of the tones and sentiment at an individual level seem to be misclassified. However, without further insight into exactly how these sentiments were identified, negative, positive, neutral, we really couldn't confirm the validity of the information provided. So the next step was to really focus on text analysis. We looked again at the source and the country of origin and tone to try to see if there were any significant words that really stood out. So for example, looking at these words clouds generated by Edward and Ping, you do see some similarities. For example, vaccine, health, community, things like that did pop up. But again, it really didn't yield as much information as we had hoped. So the next step that we went with was trying to use machine learning and natural language processing to identify the most significant terms, most significant words that would help us identify our target audience. So using the term frequency, inverse document frequency method, we were able to vectorize all of our terms and rank them in order of their significance relative to the entire corpus, relative to the entire data set. We tried to determine not just one word, but multiple terms in sequence to see how exactly their significance were relative to the entire document. Unfortunately, looking at Twitter specifically, you don't really see anything that is glaring. For example, as many would expect, Joe Biden, Prime Minister, South Africa, social distancing. These terms, while important, don't yield as much information as we had hoped because it's not really addressing the core problem of who is our audience that we should be finding a solution for. So the next step that we did was try to use topic modeling, trying to understand what were the major topics by grouped observations. What exactly were significant terms that would help us address our audience, would help us identify and address our audience. So looking at this, we tried to validate our findings by running a coherence score. As you can see here, there was different number of iterations done to help us identify which one would yield the most information, the most relevant. Running at six terms, we realized that, 6 topic models, we realized that this did address did provide more value to our analysis than others. So we focused on these 6 topics as our parameters. On the right, you'll see the key terms within those 6 topics. As you would expect, many of them included, for example, Joe Biden, UK, economics ministers. What we really wanted to focus on, though, was a target audience specified, for example, in number 4, where economic recovery was an issue, where some other ones would address, for example, the need of people based on inadequate resources or their inability to get certain resources. So using topic modeling, we were able to determine the first 2 steps. Who exactly is our audience and what were their pain points? Now on to our next solution, our next part. Actually, before I get to that, I apologize. We wanted to expand on what exactly was the limitations of the model, some concerns we had with the data, and also challenges along the way before getting to our solution. So one difficulty we had was being able to identify the health terms. So as you saw in the word cloud before, a lot of the information that was presented had to do directly with the vaccine, had to do directly with the health crisis. It really didn't have to do with the social and economic impacts or any other non-health related impacts. So being able to isolate those was a huge problem. Then identifying retweets, identifying hashtags, and being able to process those messy data out was also an issue. Another assumption that we had was that TF-IDF was significant enough to help us identify the relevant terms in our topic model. Lastly, another concern we had was that the data itself might not be representative of the entire population, as stated in the first slide. Due to its skewed distribution towards Twitter, it might not be the most reliable resource. However, since that was the information given to us, we assumed moving forward that based on our pre-processing steps, we did come up with an adequate representation of the population in question. So onto our solutions. I'll go ahead and hand this over to Dylan. This is actually a very rough scratch, a rough draft of what we were trying to do. I promise you the prototype will be a lot better. So Dylan?
All right, so to formulate a solution, we opted to create a mobile application that would target a wide audience of unemployed parents, students, K through 12, nonprofits, say entities. And through our solution, we planned on dealing with topics such as unemployment, food storage, resource allocation, and distribution. So through this storyboard, we planned out through how the application we utilized to help the user reach their solution towards the problem.
On to the next slide.
So through these different screens, we showed a home screen and access towards achieving the solution. So we have these different options that the user could select towards their specific resource that they need. Filters to help select what fit their needs, and then the results to help show where to access their resources that they needed.
Yeah, so adding on to that, I'd like to reiterate that our target audience right now are a wide variety. However, what we really wanted to do was focus on one group because this project, if it were to become a feasible solution, we really wanted to hone down and simplify so that it really goes to the crux of the problem. Our entire prototype is built on the idea of using natural language processing and machine learning to identify in real time accurate and accessible information for those who need certain resources within a certain parameter, within a certain radius. So for example, in theory, if anyone made a post, if anyone made a tweet, if anyone posted an article about some location, we could use natural language processing to identify the most relevant features within that text to be able to hone in and provide some sort of central database for everyone within a 25 or 10 or 15-mile radius access to that information. Based on volume, based on credibility, based on the user's profile, they would be able to know and evaluate for themselves the degree of accuracy, the requirements, the qualifications, things like that. Ultimately, that was our final goal. But right now, we really wanted to just focus on one objective, one simple objective that would be simple enough for a prototype to center around. So we really wanted to focus on food scarcity, on resource scarcity. So let's go to the prototype now. Dylan, would you like to walk us through this?
All right, so we have these different options that show the resources, and specifically, we had like food. We were able to show like possible food drives that are closest to the user's location. So, for example, like this location, job centers, it'll show like the route and the specific resources that will help the user.
Yeah, so expanding on that just a little bit more. This entire application's greatest feature is that it provides a central database. It allows a user control in being able to use actionable information, something that currently is not available, mainly because everything is either outdated or it's inaccessible, or there are requirements or that no one really has a full understanding of. If we can use machine learning to identify these tweets, these posts, these news articles, and use natural language processing to provide this information to people, we can essentially be that middleman that connects all the people who are in need of these resources to the small mom and pop shops who are doing these drives, or these individual users who have resources that are abundant and available and free, but don't know how to get the word out to people who need it the most. And we're not talking about just people who who are homeless. We're not talking just about people. I'm sorry, what was that?
Another minute, like your overtime.
Gotcha. Yeah, this application's main goal is to address that proportion of people who, for example, suddenly lost their job, who are now having a substantial cost because their kids are out of school and can't currently afford to pay them for that extra lunch meal that was previously provided. We're addressing a specific group that has access to a mobile platform, but at the same time does not have a specific direction to acquire resources that should be made available to them, to their people in their situation. That's ultimately our prototype. Thanks for your time.